Good morning, everyone. How's everyone doing today? I am so excited to be here. This is our 4th year doing Rev, and when we started, thank you, and when we started in 2017, we had 150 people attend. This year, we have around 1,000. We had more people do training yesterday than we had at the first Rev. A lot has changed in the intervening 6 years. I think it's safe to say that the crescendo of AI continues. And in the last 6 months, there has been a fever pitch around AI. So at Rev this year, we are celebrating companies who are all in on AI. We're going to highlight enterprises throughout this talk, see many of them here, and hear from preeminent speakers in the space. So one note before we get started, if you haven't downloaded the app, we have an app for Rev. Make sure you put a space between Rev and 4. The AI has not figured out how to do Rev 4 concatenated yet. We'll send someone to Apple to get on that. But make sure you download the app, know where you're going, and feel free to share on social media what you learned here today. We're going to dive right in. We thought, even though there are all these advancements in AI, we should go back to our roots a little bit. And we want to make sure we talk about why science is such a critical component to data science. So to kick us off for the opening keynote, we've invited an astrophysicist, the host of Star Talk, best-selling author, and the Frederick P. Rose Director of the Hayden Planetarium, Dr. Neil deGrasse Tyson.
Hey, everybody. You notice there was a brief clip there from the Jetsons. Did you recognize that clip? Okay, I don't know if you know, but George Jetson was born in the year 2022. Okay, so he's 1 year old this year, and we can all look forward to cars that make those sounds as they float through space, for sure. I'm just going to share with you some reflections on data. This is a data conference, and I realize many of you probably will know a lot of what will be in this talk. But it's just so we're all on the same page. And that's where I work, which is just uptown, the Hayden Planetarium. If you go there and you say you attended my talk, they'll still charge you $20, but they'll smile at you. And if you do not recognize these 3 icons, it means you probably read or something, you know? You have to do other things with your spare time. From the category of cheap plug, I want to alert you that a few months ago, this book came out, Starry Messenger, Cosmic Perspectives on Civilization. And it addresses topics that we've all argued about with crazy relatives over holiday dinners. And this is what society looks like when you're scientifically literate. Each of these subjects, so science and society, truth and beauty, exploration and discovery, Earth and moon conflict and resolution, risk and reward, meat eaters and vegetarians, yeah, I went there, yeah. Gender and identity, color, race, law and order, body and mind, life and death. If you look at each of those subjects through a scientifically literate lens, they're completely different from how they're being argued in civilization today. And there's a bit there about the advance of technology. This is fully explored in exploration and discovery, where you say, oh, well, planes only used to carry 2 or 3 people. Now, all right, you can say that, but when that plane flew, no one is saying, gee, it only holds 3 people. No one was feeling that at the time. It's like, oh my gosh, we have an airplane, right? So at any given time on an exponential curve, as you know, everyone thinks they're living in a special time. Cut it earlier, replot it, it scoops up right in the last few moments, and it feels like you're living in a special time. So the fact that it always feels like you're living in a special time is not evidence you're living in a special time, because it's all special. This is, of course, the nature of exponential. So all this is explored in this book. Anyhow, let me just, let me read you a quote from Edgar Mitchell, Apollo 14 astronaut, after he went to the moon. This is just to put you in a mood here, a cosmic perspective. He's on the moon and he's thinking this. You develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. From out there on the moon, international politics looks so petty. You want to grab a politician by the scruff of the neck and drag him 250,000 miles out and say, look at that, you son of a bitch. So he was feeling it right there. Okay. Let me just say some obvious things here. Science didn't really achieve maturity until we were able to transcend our 5 traditional senses. A world only coming to us through these senses makes some sense, but not complete sense. And what's definitely true about the universe is the universe is under no obligation to make sense to us. And then there's some people who run around and say, well, I have a 6th sense. You surely have met such people. Don't argue with them, just say, okay, but in the sciences, we have dozens of senses. Everything here in this list is something your physiology cannot detect. But of course, the methods and tools of science can. So give them their 6th sense, whatever it is they want it to be, and just leapfrog over them and say, we have science that completely transforms anything you think you can do with your 6th sense. So just look at everything here is a detector measuring something that your 5 senses cannot. Everything right down from the LIGO here, this is CERN, over here, there's like MRIs, Geiger counters, spectroscopes, barometric pressure. It's not the rheumatism in your knee that's detecting barometric pressure. So it's something to celebrate. Then, of course, it's interesting, this thing about measurement, because what are data if not the measurement of things, all right? And of course, some measurements are precise, but that's not even a measurement. Some things are precise, like the digits of pi. Digits of pi are not something you debate. You just write them down. But there are some questions that have no answers. Not because we haven't figured it out, but in principle they have no answers, such as how tall are you? All right? That actually has no answer. Because you would say, well, I'm exactly 5'6" or 5'8". No, you're not. You're not exactly anything. You go to it, and then you say, well, what are you exactly? Oh, it's exactly 5 feet 3 inches. No, you're not. Because you can zoom in, and when you do that, is your height like between here and here? Or between here and here? Or inside the width of the tick mark? So where are you inside this? You say, no, I'm exactly this. No, you're not exactly anything. Because measurements don't produce exact information. We just have to agree what the approximation is that we'll all accept upon making that measurement. And the most famous of these is how long is the coastline of Great Britain? This is actually its own wiki page, except they include Ireland in this. What is the coast? It is its own wiki page. There is no wiki page coastline of America. No, coastline of the United Kingdom, because it is a particularly variegated coastline relative to other land masses. In fact, it's unique in the world for this reason. So, looking at just the island of Great Britain, was that me? You're okay. I'm okay? Yeah. Oh, that's just you. Okay, I didn't know, because my phone makes those noises, and It's just a glucose monitor. Oh, glucose monitor. Oh my gosh, is that a good thing or a bad thing? I don't know. Okay, I hope that's a good thing. Okay, good. So you could find it on a map and lay down matchsticks and then look at the length of the match. You say, that's not accurate. No, you got to do better than matchsticks. Okay, so when you take a string and you can follow it around, and then you unfurl the string and then you see, okay, that's better. That's better, but let's keep drilling into this. Suppose you actually walked the coastline. Then you can ask, well, am I including these rocks? Do I go around these rocks or not? Well, the rocks are in the water, so let's just stick to the edge. Okay, I can do that. And you stick to the edge, then you say, well, wait a minute, what is the edge, okay? Is it the edge of the surf as it comes in, where the foam is? Is it, then the tide changes. Do you get an average of that? And even at the average, the water is curling around the rocks. So to do this precisely, well, you can't do it precisely. So we just have to agree at the end of the day what the quote, correct answer is. We just kind of have to agree. In my field, we are data heavy. We have been at this for decades. We, the astrophysics community, physicists as well, the military, and a few other branches of society were very early on the role of computers in assisting what we do. So we have lots of it. Most recently, I'll just give an example. There's something called the Gaia Space Observatory, which to high precision can measure a distance to billions of stars in our galaxy. It's a satellite launched by the European Space Agency. Billions of stars. Once you get distances, you have three-dimensional maps of the universe. And so, of course, no human being can sit there and analyze all of that. So it's all loaded up. And by the way, there's a difference between a computer doing an automated task and a computer doing tasks that you would have applied your brain to interpret or to understand or to catalog or to decide what is interesting and what isn't. So this is variants of AI that we have been engaged in for decades, where computers are making decisions for us. Once they're trained to look for things that are interesting, then they'll find something that we might have missed because they're better at it. So yeah, it's got the distances to 1 billion stars. Here's the actual Gaia map, okay? Everything in, try that again. Here's the Gaia map. Everything in here is there's distance data on every single spot of light in this image. And we're crossing through the center of the Milky Way galaxy. So all the light coming from this images are data points that exist and came to us from that satellite. So so we've been washing data for a long time. The data has always exceeded our ability to sort of do it by hand in all times post-photography. But how about even more of it? If you add time as a dimension to the data, it's a whole other dimension of information. We have a new telescope that just came online, unhelpfully named the Large Synoptic Survey Telescope. And someone said, well, how about Legacy Survey of Space? This is just, we can do better than this, and we did, but this is a telescope that just came online last year, just during COVID, actually. And in it, it contains the largest digital camera ever constructed, okay? 3.2 gigapixels. It is the size of a human being, okay? Why? Because now we have a wide field of view. And what we're going to do with the night sky, rather than go to a telescope and point to something and get data on that object, okay, or to just get data on all objects and put it together in one catalog, what this is going to do is image the night sky, the entire night sky, every night. All right? So, 15-second exposure every 20 seconds, 30 terabytes of data per night. It's going to operate for 10 years. Half the sky is imaged every 3 days. 500 petabytes total. Now, some of you don't need this refresher, but let me just offer it to you. Metric prefixes here. Kilo, remember days when computers, where kilo mattered. Mega, giga, tera, peta, exa, yeta, yoda. Yota, not Yoda, okay? So we're blowing through tera. Petabytes is a new sort of data volume, exabytes. So we look forward to this. This is in our future, of course, as more and more data are collected. Well, this telescope will also be able to map the existence of dark matter in the universe, and one of our pioneers of dark matter is this woman, died about 6 years ago, Vera Rubin, and we renamed it the Vera Rubin Observatory. So that was a good move right there. Yeah. Anyhow, the value of this is we now have time sampling of data, not just the existence of data of an object there in space. So time sampling. You have to watch out, though, because if you don't time sample in a way that you have to make sure you're not susceptible to artifacts of time sampling, okay? So, because if you don't do it right, it can make things that move look like they're moving backwards or not moving at all. Or can make things that change periodically look like they're not changing at all. And this is a classic experiment here with a dripping water. So this is, of course, a stroboscopic image of a dripping water, but it looks like the water droplets are stationary. You put a glass in there, and the glass fills up with these stationary droplets of water. So it's a very cool demonstration. It's evidence that those are actually moving. And depending on the matching of the frame rate of the flash rate of the strobe to the drip rate, you can make it go backwards, down, or peg it right so that it looks like it's not moving. We've seen this. But there are other examples of this that happen kind of by accident, okay? In this one, this is a security camera looking out the front, okay? And what's the frame rate? Is it like 30 frames a second? I don't know. But a bird took some interest in this. So if these are your data, I'm telling you, you're data people. I have these data. Are you going to invent a new kind of bird that doesn't have to flap its wings? Because that's what your data shows you? Your data aren't always telling you reality. It's a wake-up call to that. Oh, they stopped? Here's another one. So we know what helicopters look like and what they're supposed to sound like. Here, this is, okay? So, very familiar scene, helicopters taking off. Okay. What happens if your frame rate matches the blade rate? Well, you get this. This is very cool. And you're there analyzing your data, trying to interpret reality, and you think you have the right answer. So, this is, there's a lot of talk about racial bias or cultural bias in data or in the people who program with the data. There's also just data bias. The point of this Vera Rubin telescope is we are sampling the night sky at rates so that we're not fooled by looking at something only once a night. So that we remove what could be the artifacts of the data, of the time sampling of the data. So that's part of why that matters. And we all know there's no such thing as eyewitness data. As high an eyewitness testimony is in the court of law, it is the lowest form of evidence in the court of science. So I just give one quick example here. A few years ago, there was a total solar eclipse, 2017. How many people are here internationally? Just raise your hand, a few of you. Okay, welcome, stateside here. So there was an eclipse, that eclipse went like right across the United States. And so basically, America's eclipse, okay? The United States was the only country to get the total eclipse. So I went and viewed that eclipse in the mountains of Idaho. So I traveled from New York City to Idaho. I have relatives there, so they found a spot on a mountain. And I'm there, and then I get this text. Hi, Neil, Abby Grossberg. I produced a few segments of CBS This Morning. I'm now at ABC World News Tonight. Like most journalists in New York, I'm working on eclipse coverage. This is the morning of the eclipse. I'm sure you're slammed with requests. I'm hoping you have 5 minutes today to give us your thoughts. We would send a crew to wherever you are. Just need to be done by 5 p.m. Thank you in advance. So I texted back this photo. I said, if you can find this where I am in this photo, I'll give you the interview. Of course, Google Maps didn't know this at the time. Now, I'm talking about eyewitness testimony because here, in Boise, Idaho, after the eclipse, they have an ice cream shop. This is evidence that there's not much news in Boise, Idaho. Okay? If you want it, that's the takeaway from this slide. And let's see what they say. Neil deGrasse Tyson was rumored to have stopped at Delsa's ice cream parlor more than once in recent days, and one of the servers confirmed he saw him there Saturday. Heard Tyson stopped by en route. What flavor does an astrophysicist choose? So this keeps going, okay? The astrophysicist tried a couple of different ice cream flavors, including the popular hot fudge Eclipse, she said. That's made with vanilla ice cream, hot fudge, Reese's peanut butter cups. Tyson also tasted the sweet potato with marshmallow ice cream, she said. I did go to Delsa's, and I ordered my favorite flavor of ice cream, which is strawberry. So, either they just made all of this up, or I went to Delsa's, left, and then the other black person in Idaho went to this thing, okay? So this thing about eyewitness testimony, oh my God. You saw the article recently, and it was a big op-ed in the New York Times. Article said that mask wearing made no difference to non-mask wearing, whether you catch COVID or not. This was big news. And I thought to myself, wait a minute, if mask wearing made no difference, this is a major discovery about masks. Then why is any surgeon wearing masks? This would be a major discovery. It's not just, oh, because COVID, heck, that's a big, so what actually happened? They interviewed people. Did you wear a mask today? And they say, yes. And you know, half the people you met who wear the mask, you know what they do, okay? Okay? They wear it like this. Okay? This counts as wearing a mask. Sorry. This counts as wearing a mask when you're interviewing people. And they're going to put that in as data? Damn. Get me angry. Okay. Now, let me tell you something interesting about how data, so I won't spoil it. I'll just go straight in. Okay? The good, the bad, and the ugly. This colonial-looking fellow is William Herschel. He discovered the planet Uranus, quite by accident, actually. No one had discovered a planet before. All the known planets, Mercury, Venus, Mars, Jupiter, Saturn, were known to the ancients, so there's no discoverer of those. They're bright enough in the night sky. He discovered this via his telescope. All right, when that discovery was made, here's a modern image of it. What they found was that it was not following Newton's laws of gravity. So people are saying, whoa, maybe Newton's laws of gravity has a limit to how far it can be invoked. Maybe it doesn't work past Saturn. So it's only a local phenomenon in our galaxy. So no, it's not a universal law of gravity, it's a solar system law of gravity. So then, yeah, maybe that's true, but a team of, wasn't a team, it was independently, this is a picture of John Couch Adams' forehead. So you have a Brit, a German and French, two mathematicians and an observational astronomer. They thought to themselves, maybe Newton's law still applies, but there's an unseen planet out there beyond Uranus whose gravity is tugging on it in a Newtonian way. But if you don't think it's there, you think it's disobeying Newton. So they solved the inversion problem. Rather than know your masses and calculate the force of gravity, they said, what force of gravity would be necessary to perturb Uranus in that way? And so it's an inversion problem, very complicated, especially pre-computers, automatic computers. So they did this. They calculated, and by doing so, they said, look, after all the calculations were done, they said, look here on the sky tonight. They sent that to John Gall, and bada bing, Neptune was discovered. Oh, I left something out, sorry. No one had discovered a planet before, so no one knew how to name them. Well, he was in the service of King George, George of the American Revolution, that King George. And so he decided to name his new planet after the king. So I have books that enumerate the planets from, so it was about 30 years where this was the case. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George. It was about 30 years where we had a planet George, right? Just thought I'd tell you that. Okay, let's pick up the action. And so, all right, this is a modern image of Neptune. So fine, so now Uranus is not disobeying Newton. So it's a triumph of Newton's laws. Newton's laws extend at least out to Neptune, out to Uranus, and probably Neptune. Well, we start looking at Neptune's orbit. It's jiggling, it's not exactly following Newton's laws. Well, we've been down that road before. This must be another planet out there, so let's search for it. Let's search for planet X. So Percival Lowell, who started, of the Lowells of New England, he built his own observatory in Arizona on a mountaintop, had very good sight lines to the sky. It's desert, so there are few clouds. And he's rich. Guess what he called the observatory? The Lowell Observatory, yeah, okay. You get to do that when you paid for everything. And so he said, let's find this mythical planet X. So we looked at the perturbations on Neptune, so it should be there, because we did this before. People looked, they didn't find anything. Well, maybe it's there. Couldn't find it. So he said, let's do a systematic search over the entire sky. So that's what he did. Tasked Clyde Tombaugh to do it, and in so doing, he discovered Pluto. Everyone was excited. Once again, a triumph of Newton's laws, but was it really? Well, it wasn't where we think it should have been to perturb Uranus in that way, to perturb Neptune in that way. And then the more we learned about Pluto, the smaller it got. Every next measure, no, it's not as big as we thought. Get over it, by the way. It was justifiably kicked out of the planet status. And I have hate mail from children because I was implicated in this demotion. I didn't demote, but I was definitely an accessory. I definitely drove the getaway car on this one. Pluto, our moon has 5 times the mass of Pluto. There's no way Pluto could have perturbed Neptune in this way. So we found Pluto, but it was not the mythical planet X. Okay? This is the discovery image of Pluto. And Clyde Tombaugh had a great response to this. He said, how did you know that was Pluto? He said, it was easy. There was an arrow pointing to it in the sky. So, anyhow, so this planet X would so Pluto is not planet X. It's just not. Neptune still had issues. We would later learn in the 1990s that no, there is no planet X. There's no dynamical evidence from optical observations. Why? What people were doing was at the US Naval Observatory over those 10 years, it was observing Neptune. And what they found is that was bad data. Something happened, like the guy changed the gearbox or something. They did something different from what people were doing before and after. So what Miles Standish did was, let's remove the Naval Observatory data from all the other data. Because these objects don't move very far, night by night. And you want to get a full orbit, you need a big, wide range of data. Okay. So he removed that. Upon doing so, Neptune landed right on Newton's laws. There was no need for a planet X ever. So the lesson here, which is a hard-earned, sorry. Mercury's orbit, the closest planet to the sun, was not following Newton's laws. So, all right, we got this. Let's search for another planet. So we invented a hypothetical planet called Vulcan, all right, which is the god that gives us volcanoes. So it's hot. It's near the sun. How come no one has discovered it? Because it's so near the sun, it's lost in the sun's glare. So here's Mercury, and what's happening to Mercury is that its orbit is precessing around the sun. So every time it makes a loop, the loop starts out in a slightly different direction. It would not do that under Newton's laws. So everyone said, there's got to be a planet Vulcan there. Of course. Of course. No, there was no planet Vulcan. 1916, Albert Einstein introduces an upgrade in the laws of physics, the laws of motion and the laws of gravity, the general theory of relativity, demonstrating that under strong gravitational fields, the laws of motion do not follow Newton's laws. It's general relativity. It's a different physics model, okay? So it explained it, and Vulcan died overnight. It was unnecessary. Here's the point. In the first case, what we thought was a failure in Newton's laws led to the discovery of a planet and an affirmation of Newton's laws of gravity. Case one. Case two, the failure of Newton's law of gravity was an illusion, and it was the consequence of bad data. Case three, the failure of Newton's laws was an actual failure in his laws, requiring Einstein's theory of relativity to resolve. So I want your sympathy for what we have to go through as astrophysicists. But you as data scientists and data managers, the very framework in which the data are embedded may itself be flawed, so that even if the analysis is accurate within itself, the fact that you're doing this analysis instead of that is what could be flawed. So, is there any hope for any of this? Maybe. I'm going to end with a few slides here. There was a science march. People were worried that science and technology, that we were undervaluing it. But there's a march on Washington. This was remarkable, actually. Just look at some of the posters people had. What do we want? Evidence-based science. When do we want it? After peer review, okay? These are very, very geeky posters. I like this one. Forget princess, I want to be an astrophysicist. That's my favorite one of them all. And then people said, no science, no beer. Got the plague? Me neither, thanks science. Society should worry when geeks have to demonstrate. That's, I think, the most important message there. This is really geeky. I was told to bring a sign. That's the best one, perhaps. And then Santa protested, my workshop is melting. How about time to react? I like that, with a little flask. No science, no Death Star. And this one, I swear to you, I never uttered this sentence, but someone had a poster of me saying, y'all need science. All right, that's my final slide. Thank you for your attention. Thank you.
Neil, that was great. Thank you so much for joining us today. I'm Matthew Grenade. I'm one of the co-founders of Domino, and I get the privilege of asking you a couple of questions. Sure. Let's start off. AI has been used in astrophysics for a long time, so it's obviously having kind of a societal moment. Are you optimistic or pessimistic about how things are going to go in the next 10 or 20 years?
So the dire predictions for AI make very good media clickbait, as of course you know. The public now thinks of AI as an enemy of society without really understanding what role it has already played in society. I think once you become accustomed to something, you no longer think of it as AI. The fact that I can talk into my cell phone and say, where's the nearest Starbucks? I want to get there before it closes, and I need the shortest traffic route. It'll give me that answer in moments, and not a single human being was involved in that decision. So again, this is not a computer doing something rote. It's a computer figuring stuff out that a human being might have done and would have taken longer. No one is calling that AI. I mean, why not? It kind of is, right? So how we've been using computers from the very beginning, I've probably coded 50,000 lines worth of programs. And I've watched the power of computers grow. Anytime it got powerful, I said, let it do what I was previously doing, so I don't have to do it. It was like a celebration of the power of the computing. So part of me, just a part of me, sees what's happened in recent months, where this AI power has crossed over this line in the sand, and now it's affecting people in the liberal arts world. They can now compose their term paper, and they're losing their shit. Oh, they're freaking out over this. And I say, what do you think it's been doing for the rest of us for the past 60 years? When it beat us at chess, did you say, oh my gosh, that's the end of the world? No, you didn't. You were intrigued by this. And it beat us at Go. It beat us at Jeopardy. And you, okay, oh, now you can write a term paper and you're freaking out. So I'm more optimistic. Yeah, I think you need some guidance, of course, as you would any powerful tool. The AI, I don't think, is uniquely placed to end civilization relative to other powerful tools we've created, like nuclear weapons that are controlled by computers, okay? So it's a matter of getting people accustomed to this thing that's new. And yeah, you put in some checks and balances. But the idea that some humanoid robot is going to come out, that's not the direction we're going. They make an occasional one that like has eyebrows and can smile at you, and it's in that, what do you call that valley of, what's that called? The uncanny valley. It's the creepy valley is what they should really call it. Yeah, that's not the direction things are going. When you look at pharmaceuticals, you look at aviation, you look at all the other ways AI is being applied. No one clickbaits on that. They clickbait on these other things. There's a movie, what's the one with the little girl who helps the girl? Yes, you know the... Megan. That's some creepy stuff going on in that film. Make anyone scared to death about progress in AI. So it's a hard problem because people fear what they don't understand. But you have people, heads of AI, captains of industry saying, we should fear this. And we presume they understand what they're talking about. So my reply here is, yes, we should fear it enough to monitor our actions closely about what you're doing with it and why. I was on a board of the Pentagon, the Defense Innovation Board, where we talked about the role of AI in a kill decision. And we said in the ethics of this, if there's such a thing as the ethics of war, is AI can never make that ultimate decision in any command chain. There has to be a human being in that loop. That was a very strong recommendation that the military adopted. So now another side of this is the fun part, is the capacity of AI to do deep fakes of voice. Wasn't that not Steve Jobs reading? That was like not Steve Jobs, right? Okay. So here's what I think is going to happen, just between you and me. You can listen to this. Okay. The capacity to make deep fakes will be so effective that the people who used to believe fake news won't even believe it. Okay? So the people who were sure that Democrats were eating babies in the basement of a pizza parlor in Washington, D.C., they will even question that.
Right.
No, think it through. It's like this chess game. 4 moves down, nobody can trust anything, even the people who didn't used to trust things.
Right.
They can't even trust the things that were wrong that they trusted. So that's basically the end of the internet. The internet becomes an entertainment space, not a source of information, and people will return to having one-on-one conversations with each other and actually calling people on the phone. And the internet will just be this playground of fake things. And then that'll be the tombstone, the internet. 1992 to 2004, 32 years, it had a good run. Rest in peace.
And so if we take something like vaccines, which I saw a headline just yesterday that people were getting more and more skeptical because of the reaction to the COVID vaccine. Do you think we're going to enter into a world where the conversations are going to start happening and we can reach a turning point? Because right now it seems truth is fairly imperiled.
Truth is broken.
Truth is broken.
Yeah, and the internet will continue to break it thoroughly. So you must know about this statistically, that a disease that kills like 3% of who get it, COVID was in the low single digits, can end up killing more people than a vastly more lethal disease. So what happens is if COVID were like 50% lethal, then no one would say, no, I don't think I need the vaccine. No, I'll sit this. No, everyone gets vaccinated. And everybody takes measures immediately so that while if you got the disease, there's a much higher likelihood of you dying, but many fewer people would end up getting the disease. So statistically, fewer people end up dying. That's the interesting, non-obvious consequence of a more lethal pathogen. So, maybe the problem with COVID is that it was not lethal enough for people to jump to. The problem with climate change is, okay, it's not really at a level yet to take out the rich person's second home on the beachfront. You don't applaud that. And what just happened in California? State Farm refused to insure homes against wildfires. This is the evidence. The scientists, the military, and insurance companies are the lead people who understand climate change. And everyone else will just come behind. So yeah, truth is broken. It may require higher lethality to bring truth back to experts. And that would be a shame and a tragedy if that were indeed the case.
We probably only have time for one more question. So, I mean, this
Can we get one from the audience, or are you asking all the questions?
I
know you co-founded the company and everything, but these are your guests here.
They are. I got these questions from the audience, so I surveyed. So
okay.
So last one, unfortunately.
No, I can answer. Ask me two more, and I'll answer each in half the time.
Okay.
If you do the math on that, it works out.
Okay.
Okay. Go.
This is a collection of data leaders. What's your advice to them? I mean, in this world that we're living, that we're talking about right now, like as they try to lead their companies?
Yeah. So I sit at the intersection of the bleeding frontier of science and public awareness and appreciation of it. I know there's been attempts of companies, IBM especially, to bring AI to the public and have them embrace it with ads. But movies that show the apocalyptic directions it can take and the clickbaiting of news headlines is a powerful force. And so maybe there needs to be an ad campaign about the AI that people already embrace in their lives and have forgotten to call it AI. Just think of every decision getting made in your life that didn't involve another human being, that was not just some rote automation of a machine. That's an ad campaign right there. And be honest about, yes, in the hands of bad actors, yes. And that's not a new problem with new technology. That's an old problem with new technology. But society as we know it, even living it today, would be unrecognizable if you subtracted the AI that we currently embrace. It's just that, like I said, no one is calling that AI. No one calls Siri AI. You know, if you brought Siri back 30 years, they'd resurrect the witch burning laws and burn you at the stake for having some mysterious device. So, and that's only 30 years. So I remember, sorry, I'm not taking half the time to answer this question, am I? In the 1970s, I was introduced to software called Eliza, which was an early version of a Turing test, where you'd ask a question and Eliza would speak back to you. Well, it was a teletype, because that's how old I am. And you say, oh, hi, my name is Neil. I'm Eliza. How are you, Neil? How are you today? I'm fine. Some problems at home. Tell me about your problems at home. Well, my mother made me. Tell me about your mother. And what kind of a kid were you? So asking questions. It knew what the nouns and verbs were, knew how to create a sentence, send it back to me to have me keep talking. That's what any therapist does, really, when you think about it. So as far as I was concerned, AI had already landed and the Turing test was already satisfied in 1976. All right? But now we're way beyond that. No one's calling that AI. Well, it was AGI, okay? Artificial General Intelligence. And they're moving the goalposts. And as long as they move the goalposts, no one will know how much AI is currently in their lives. So somebody's got to back up and say, take a look at all of this. Mm-hmm. Yeah, it's AI. So if it was not really AI, no, it's AI. Is a human in the loop? No. Is it making a decision that you would have made, could have made, is make it better? Then it's AI.
And these people have to make sure everyone understands that.
Yes, because so you need among you those who can be interviewed by the press. Yeah, I'm a data scientist, and this is what we do, and I love my job, and this is how the world is different because of it. And yeah, there are people who will abuse the data, who will have bias in the, yes, you can't sweep that under the rug. So what you then say is, we have an ethics panel, or we have a, we field test it for the potential of bias. But everyone is going to focus on that and ignore everything else that's in our lives. So I think that's what needs to be teased out of civilization and our culture,
awesome.
and offered on a platter. So people say, I don't want to live in any other time.
Yep. This was awesome. Thank you so much, Neil.
Thank you.
It's great having you. Neil Tyson.
Thank you.
Thank you.